Okay, we're in section 3.3. We have been finding the zeros of polynomials, and in the next couple examples we're going to turn the problem around, and this time we'll be given the zeros and we'll ask to find a polynomial function that has those zeros, that meets those conditions. And so the key to remember is the factor theorem. The factor theorem says if k is a zero, then x minus k is a factor. If k is a zero, then x minus k is a factor. And so let's go ahead and get right into it. In example 3, we want a polynomial, degree 3, real coefficients, with a 0 at 0. So if there's a 0 at 0, then there must be a factor x minus 0 by the factor theorem. And if there's a 0 at 1, there must be a factor x minus 1. And the multiplicity 2 means that the exponent on that factor is 2. And notice when you have x here times x squared times x squared here, that will give us x to the third power for the leading term. That will give us degree 3 that we're supposed to have. There's just one more trick, and that's to make this function pass through the point at 210. And so let's see here. Let's make a note of that. When x equals 2, y equals 10. And the way we're going to do that is with a factor a constant factor a that we could think of like a vertical stretch or a vertical compression, if we remember that from the last chapter. This factor a will stretch or shrink the function so that it just passes through the point at 210 without changing where the zeros occur. Okay, so let's see here. Let's go ahead and clean this up just a little bit. So f of x is equal to a times, mostly instead of writing x minus 0, I just want to write x. So we have a times x minus 1 squared. And then we just need to find a. And so what we're going to do is we're going to plug in x equals 2, y equals 10, and solve for a. So y is 10. That's the same as f of x. 10 equals a times x is 2 times 2 minus 1 squared. 2 minus 1 squared. And so then we can just solve that little equation for a. We'll have 10 equals a times 2. Right? This is 2 minus 1 is 1 squared is 1 times 2 is 2. So 2a equals 10. Or a equals 5. And so then we can just go ahead and plug that in to our function. Remember we said this equation right here is exactly the answer, except we need to know what a is. Now we know what a is, we can plug that value of a back into this function, and we'll have our final answer. So we'll write f of x is equal to 5x times x minus 1 squared. And then you should be able to look at that and check that it's correct, check that it actually satisfies the conditions listed in the problem. Okay, let's do one more. It's just a little bit tricky, but it's not too bad. I'll explain the conjugate zeros theorem in just a minute, but let's just go ahead and get started on the problem first. So the problem says find a polynomial of least degree with real coefficients with zeros at -1 and also 1 minus 3i. So we'll use the factor theorem again. Since there's a 0 at -1, there must be a factor x minus -1 or x plus 1. There's also a 0 at 1 minus 3i, and so we can write a factor x minus 1 minus 3i. We haven't written factors like that before, but we could have. We didn't have any use for it, and so we avoided it. But it's certainly okay. And then the last thing is if you have it is the conjugate zeros theorem, and it says that if you have a 0 at 1 minus 3i, then you also need to have a 0 at 1 plus 3i. You also need to have a 0 at 1 plus 3i. And so we'll see that's true when we multiply this thing out in a minute. We'll see that the conjugates are going to cancel the imaginary parts and leave us with only real coefficients as we're asked to have. So let's go ahead and write that last factor, x minus 1 plus 3i. This problem is a little bit different than the previous problem. Remember, the previous problem said you had to have degree 3. This one doesn't say that, it just says least degree, which it in fact will turn out to be degree 3 because of the 3 factors that we have here. But the other difference is that in the previous problem, you had a particular point. I think it was f of 2 equals 10 or something like this. This time we don't have to worry about that, so we don't need a factor, a constant factor up at the front to accommodate for that. We can leave this as our answer. We can go ahead and call it f of x, and it looks real good. The only thing that we'd like to do is just clean it up. We'd like to multiply it all out, which is a little bit tedious, but it's good review. We'd like to multiply it all out and get this polynomial into standard form. And the other nice thing is we'll see that the i's fall out and we're left with only real coefficients. So let's go ahead and leave the x plus I where it is. Let's get rid of the parentheses inside the brackets in the next two factors, x minus 1 plus 3i, and then this will be x minus 1 minus 3i. And then what I'd like to do is I'd like to go ahead and multiply these two factors together. So I'm just going to bring down the x plus 1 for now, and then I'm going to multiply, I'm going to distribute to multiply these two factors together. So I'll have x times x is x squared, x times negative 1 is minus x, x times negative 3i is negative 3ix. And then I'm going to keep going like that. I'm going to multiply negative 1 times each of these three terms, and I'll have minus x plus 1 plus 3i. And then I'm going to multiply the 3i times each of these three terms, and I'll get plus 3ix minus 3i minus 9i squared. So that's probably the tedious part, and now it should start to clean up. We should see a minus 3ix and a plus 3ix, and we should, so they cancel. We have a plus 3i and a minus 3i, they cancel. This I squared down here at the end is equal to negative 1, and so the minus 9i squared, so this whole thing is going to be negative 9 times negative 1, which is plus 9. And so I can combine like terms. I have x squared minus x is going to be x squared minus 2x. And then I have a plus 1 plus 9 is going to be plus 10. There you go. Just for fun, if you wanted to, you could take this little quadratic here, you could set it equal to 0, and you could solve. And do you know what the answers would be? 1 minus 3i and 1 plus 3i. Okay, one more step here. Let's just go ahead and distribute again. Let's multiply x times x squared and get x cubed. X times negative 2x is minus 2x squared. X times 10 is plus 10x. And then multiply the 1 times each term and get plus x squared minus 2x plus 10. And then we can write our final answer. We can write x cubed minus 2x squared plus x squared is going to be minus x squared. 10x minus 2x is plus 8x plus 10. And there's our answer.